Cloud computing infrastructures have grown out of new capabilities provided by server virtualization, hypervisor-based server virtualization from companies like VMware, Microsoft, Citrix, have allowed IT to implement infrastructure that's extremely flexible and can provide virtual server services or virtual application services in a very flexible manner on an as-needed basis. The issues that come up are that there's a whole set of applications, probably 20 or 30% of applications within a corporate IT environment, can't run within a single server and therefore can't run within a single virtual server. Those applications include data warehousing, business analytics, most engineering type applications on EDA, CAD, those kinds of environments simply need more resources than you can get into a single x86 box. ScaleMP was really founded to try to solve some of those fundamental problems, to address the larger set of applications that need more requirements than you can get into a single box. What ScaleMP delivers is a solution, a technology called vSMP Foundation. vSMP Foundation is a hypervisor in exactly the same way as ESX is a hypervisor that VMware sells. What our hypervisor is tuned and designed for, though, is exactly the opposite utility that an ESX is. Where ESX or Hyper-V from Microsoft are about partitioning a single server into many virtual servers. You've got more technology capability in a single x86 box than most applications, or about 60% of the enterprise applications, can ever address. So they create and carve up and partition a server into many virtual servers and create a lot of fluidity and a lot of dynamism in those environments. What we do is we have a server virtualization hypervisor, as I said, called vSMP Foundation, that actually aggregates many x86 boxes into a single large SMP. Originally, this technology was designed to solely address the issues around performance and cost of traditional SMPs. So traditional SMP, a customer who wanted lots of processing performance or lots of RAM or lots of I/O, the only choice they had was to buy an HP Superdome or an IBM P-Series or an E25K from Sun or a large Cray box or something like that. So what we did was design the hypervisor to allow you to use smaller x86, inexpensive commodity x86 boxes, aggregate them together into a large many processor, large RAM SMP. A significantly reduced cost, actually get better performance because now you get to ride the Intel cost curve. Run into many customers who said, well, this is great, but allow me to aggregate cloud nodes. Allow me to aggregate those resources that I've already paid for in the cloud. And that's really where the core and direction of the company is, helping customers who've already invested in the infrastructure, the cloud infrastructure, to get more utility, to get a greater ROI from that by addressing almost 100% of the workloads that they have in their environments. Using the vSMP Foundation aggregation platform from ScaleMP, you can aggregate up to 128 x86 nodes to create a single system with over 255 processors and over 4 terabytes of RAM. So again, in your cloud environments, aggregate those nodes, create a large system, run the workloads, and when you're done running those workloads, like a BI workload that you only need to run once every quarter, you can then disaggregate those nodes back into the cloud and make those resources available for other applications. In a nutshell, applications that gain performance benefit from many cores, or applications that need lots of additional resources that you can't simply get into a single box. So a single x86 platform today has about 128 gigs of RAM. That's great, but what if you need 500 gigs of RAM? What if you need a terabyte of RAM? And we default often to the data warehousing conversation because data warehouses often exceed the limitations of a single box. And that's something every enterprise has, that challenge. So on the HPC side, there are lots of applications that benefit from many cores. There are lots of applications that benefit from a lot of memory. And quite frankly, there's high-performance clustering environments that also benefit from this from a management and ease of use perspective. So there's lots of use cases, but they generally represent a smaller footprint within an enterprise. So they're the last to be addressed. And the value that we're providing now with our cloud offering is the ability to address those with existing infrastructure. For cloud customers, they already have the infrastructure. They already have those nodes out there. The question is, how can they take advantage of a new technology to better utilize that infrastructure, whether it's 1 or 2 nodes or 4 nodes. And for that matter, 1 or 2 virtual servers, right? I might have a virtual server that's just come off the job. I don't want to move that virtual server somewhere else. I might need it later on from a scheduling perspective. I know there's a workload coming up, but can I use it for the next few hours, get greater utility from it? And one of the hidden benefits of vSMP Foundation for Cloud is we can aggregate not just nodes, or not just x86 boxes as nodes, but actual virtual servers as nodes. So it's an added layer of utility on top. If any company out there is ever considering buying any kind of a large SMP or a large processor or large memory type of system, they should stop, go to our website, ScaleMP.com, and take a look at the value propositions we've posted and the performance benchmarks we've posted. We can not only save those customers a dramatic amount of money, we're talking about an order of about 20% the cost of an existing SMP from HP, IBM, Dell, whomever you're going to buy your traditional SMP from. But we can also provide much better performance for most of those applications. The value proposition is quite strong and very proven. We've got a lot of use cases. We've got over 150 customers using our solution today in real-world environments. We're breaking performance records every day, and we're really extending the ROI of the investments they've already made.